Alright, last time we were talking about 657 to 659. I gave you 4, 9 through 11, 13, 15, 25, and 26. And so what I would do at this point is I would get 9 through 11 for sure on the board. So these ones, 9 through 11, 13, 15, no. And then, yeah, I would get at least 9 through 11 on the board so that people know what's going on. After you get those done, or while people are working on those particular problems, I would highly encourage you. You wouldn't have had homework on this because this is your Wednesday. So I would get those on the board and I would cover those. So let me just go back real quickly. I would get these particular problems and I'd go over the answers. So 9 through 11 quickly, and then even if we have to just give the answers to these ones, students will figure it out. They'll help each other. They'll get it. But I believe in you guys. I know you got it. So 10.4. So we're going to 10.4. This particular lesson is 10.4 using inscribed angles and polygons. And so let's get this going to where it's a certain size. All right. So this is going to be on page 662. 662, you can go there. An inscribed angle. An inscribed angle is an angle whose vertex is on a circle and whose side contains chords of the circle. The arc that lies on the interior of an inscribed angle and has endpoints on the angle is called the intercepted arc. And so in the last couple lessons we've been working with, of course you had your circle. Let me see if we still have our circle, or standard circle here. You had a circle, and when you did this particular one, let me move this over, you had a center, and we had something that would form like this. We'd call this a central angle. This particular one is called an inscribed angle, and I think that comes from the concept of an inscribed figure. And so when you think about a triangle or something like that that would be inscribed inside of a circle, it would mean a triangle whose vertices all touch the circle. So an inscribed angle's vertex will be on the circle itself, and so you'll notice the vertex that's located here. Now it says an inscribed angle is an angle whose vertex is on the circle, and whose sides contain chords of the circle. So you'll notice that these particular pieces here, I'm not putting those marks to say they're equal, I'm putting those marks to highlight them for you. Those particular pieces are chords, and so you'll notice the chords that are drawn. Now this last portion is what's called the intercepted arc, and so the intercepted arc is the piece that the angle touches, and so it intercepts it. So we call these angles inscribed angles, and those inscribed angles form intercepted arcs. Now it also forms the top and bottom arc that you'll see in these positions too. They don't have names. They're not as important as the intercepted arc. From here, this is something I would just put in my notes. I would actually have all of this, me personally. And there are 3 ways that an angle can be inscribed. You'll notice in the first example, central angles, we talked about those already, but we had the center right here, and it was between the two chords is what we call them. In these ones, here's your first case. Case 1, center P is on one of the sides, and so you can have the angle actually touch P. You can actually have P between the 2 rays, and you can have P outside of the 2 rays. But all 3 of these are inscribed angles. So I would give you a second to pause the video, or even to write this down very briefly, and make sure you have the 3 cases in which you can have an inscribed angle. Now, they're all inscribed angles. But when we continue to do the math, it's helpful to understand what kind of angle we're dealing with at what point. All right. For each of these cases, the following theorem holds true. Okay. Let's go ahead and hold that, and let's look at theorem 10.7. 10.7 is on 662. It says the measure of an inscribed angle is 1/2 the measure of its intercepted arc. Alright, so we have our circle, and we said we have an inscribed angle. So inscribed angle, you've got your vertex, it does something like this. It does something like this. Now this section between the two arms of the angle is called the intercepted arc. And so if this is 110 degrees, how much is the unknown angle? Well, it says the measure of an inscribed angle is 1/2 the measure of the intercepted arc. Well, the arc is 110, therefore this is 55 degrees. And that's all it's saying. And vice versa. The arc would be double the angle. From there, this comes from a graphic that's online. This is not original with me, but I think it's incredibly helpful. You're going to be learning more and more of these different types of angles. So the first one we learned was a central angle. You'll see this on the left. And so central angles are equal to the arc. And so if this is 100 degrees, then the arc's 100 degrees. And by the way, there's a central angle on this side too. If this is 100, this would be 260, which means this major arc would be also 260. Over here, though, this inscribed angle would be 1/2 of the arc that it intercepts. And so let's say this is 60, then this is 30. And it's always going to be half of the other angle. So you first of all have to establish, is it a central angle or is it an inscribed angle? And I can tell simply by, if it's a central angle, its vertex is in the center. If it's an inscribed angle, it's going to be touching, its vertex is going to be on the circle. And so we can measure those based on that. Alright. Example 1. Find the indicated measure in circle P. So, find the indicated measure. And so we have two types of angles. What kind of angles are these? They're not central angles, they're inscribed. And so just to get that word kind of floating around in your brain, it's an inscribed angle. Okay, well, inscribed angles touch arcs. And so you'll notice this 50-degree angle right here and this arc that it intercepts. Also, you will notice that there is a arc that's intercepted over here that's 48 degrees, but there's also an inscribed angle here. Alright, so it says find the measure of angle T. Well, the measure of angle T is equal to 1/2 of 48. Okay, look over here. So we got angle T. We don't know it. It's X, right? And it's actually, I would say this is X. Well, this is 1/2 X. And since X is 48, we would say that measure of angle T is 1/2 48, which is going to be 24 degrees. So that's all there is to that particular problem. Now, letter B says, so this was an angle. Letter B says find the measure of the arc QR. Okay, well, arc QR is up here. Now that's actually much more difficult to find. So first of all, we need to know kind of everything about this circle. Remember, the arcs going all the way around make up 360. My question would be, are there arcs that we can know, that we do know? Well, obviously this question mark is going to be double the 50, so this is going to be 100 degrees. Okay, that's going to be 48. Let me get rid of this X. So now we've got those two. Do we have any other angles? Is there anything else we can know? And so even looking at the example here. Okay. Oh yes, of course. So I was thinking through here, I'm thinking, oh, I'll find this. Well, I don't know that I can find the bottom, but I do know that TQR makes a what? What arc is that? It's a semicircle. And I can tell that because it's a straight line. Well, a semicircle is how many degrees? It's 180. And so if this one over here is 100, TQ is 100, then QR must be 80. And so that's all there is to it. And so QR is 80 degrees. Now, taking that question further, if I had to find the bottom, I could say, well, that's 180 plus 48, that's going to be 228 from 360. Okay, so that's going to give me a 5, this is going to be a 10, this is going to be a 2, 3, 1, 132 degrees, and so there's your bottom. Okay, and now I know every arc all the way around this thing for 360. Make sure my math's right there, but I believe that's correct. Okay? All right, so that's example 1. Here's example 2. Notice these are not central angles, these are inscribed angles. Their vertices touch, and actually this one makes 4 of them. 1, 2, 3, and 4. Now these are vertical angles. So it says find the measure of RS. And so I'm looking over here, and I'm looking, and I'm noticing RS is just simply right there. Now notice that that is between the 2 rays of our angle U. Okay? And so we would call that the intercepted arc. So find the measure of RS. Well, the measure of RS is 2 times 31. Okay? So it must then be, let me use a dot instead of an X. The answer is going to be 62 degrees. So this particular one's 62 degrees. Now it says, what do you notice about STR and RUS? So STR and RUS, what do you notice about those? Well, notice that this particular one touches, and that 62 is between both of them, both of those points. This angle and this angle are both 31 degrees. And so the thing you're supposed to notice about those is they both touch an intercepted arc, and they're both half of it. And so that's the main concept. Based on that, you have a new theorem. Here it is. 10.8. If 2 inscribed angles of a circle intercept the same arc, then the angles are congruent. I don't know that I need to draw that, because I think that's what we proved up here. So if they intercept the same arc, then the 2 angles must be equal. Both of those were 31. So I'll give you a second to write that down. You can even pause the video if necessary. All right, here's example 3. Example 3. Example 3 says standardized test practice. So we're getting ready for these things. You got usually about a minute per question. Name 2 pairs of congruent angles in the figure. And so it says, all right, well, obviously it's going to be this one and this one. Now also it's going to be these 2, and notice they're not exactly equal to each other. These ones on the left are equal to each other, and the ones on the right are equal to each other. That's the new rule we just learned. Because notice, if I take this particular angle all the way through, and I take this particular angle all the way through, it is connected to the arc JM. And so these 2 angles are both equal, and they're both half of JM. Now over here, angle J and angle M are both intercepting KL. KL is the intercepted arc. And so they're both equal to each other. That's what we just learned. And so those are our values. And so now all I simply have to do based on that is look at the options that are true. So I have an angle J is equal to angle M. So I look through here and I find the one that has a J in the middle. There it is, KJL. So KJL, yep, I want it to say that. And then I'm looking for an M in the middle, so that's going to be KML, like that. That's true. So these 2 are congruent. I agree with that. Now let's check the other one. So K is in the middle, yes, and L is in the middle, good. And so I'm looking through that, and I'm going JKM, yes, and JLM, yeah. And so both of those are correct. So my best answer for this one is letter C. C is easy. It's exactly what the rule is wanting me to say. All right. So now I'd like to take a moment and do guided practice numbers 1 through 3. Take a minute, do those at your seats, and then we'll come back to it. Alright, so now you've had an opportunity to take 3 of these. We'll do just a little bit here with the time that we have. Here's number 1. So you've got kind of a center of this, and so it's got letter D here, and then you've got an inscribed angle. So something goes all the way through the center and kind of comes over like this, and then you've got an H, you've got a G, it looks like, and an F. Okay, you got an angle. This is an inscribed angle, and it says that the intercepted arc is 90 degrees. It says find the measure of the arc or the angle. So we don't know the angle. The angle is what fraction of 90? 45. Now notice, if you got that confused and you would have said it's double, look at the angle. There's no way it's 180 degrees. And so you can use your logic there. So the answer is 45 degrees. Here's number 2. Okay, similar picture. Get our circle going. Similar picture. You've got a center. Nope, doesn't even care about centers. So it's got that there. It's got a U up here. It's got a T somewhere down here, a V, looks like. And so it makes a inscribed angle. Ooh, we got curved angles now. And so this is a 38-degree angle. And then this particular one is TUV. Okay, so it says find the arc. Okay, at this point you should be saying, oh, it's double, it's double. Remember the angle's half, so this must be double. And so we double 38, that's going to give us 76 degrees. And so there's the answer for that one, number 3. Of course, this one is much more complicated. They have all kinds of lines. Now this particular one has a point here. It has a point here. It has a XW over here. Okay. Now it's on purpose drawing this kind of hourglass shape. Okay. Okay. Something like that. And it says that this top left one is 72 degrees. Now this is YXWZ. Okay. Nope. YXZW. Yeah, I got it. Alright, so it says find the measure of the red arc or red angle. Okay. Of course, I have no problem. It seems to be this line right here that it's looking for, but I'm pretty much going to find it all. So it looks like it's asking, since it's highlighting this, it's saying what's the angle. Well, since they intercept the same arc, they're both the same. That's all there is to it. This is 144 degrees. Now it's only looking for this, but we took it a step further. Today you're going to be doing a lot of extra work, so you'll notice page 666. You're going to be working on numbers 3 through 7 odd. Take a moment, pause the video, and get those done. And then your proctor can read you some answers, but we'll be on page 666 for the remainder of our time. Alright, so now that you're back, this really was a short lesson, but I'm going to give you the rest of the time to either work on take-home quizzes or this extra assignment here. You'll notice that I didn't really go over a lot, so I needed to give you some extra stuff. So you'll notice this page 700 assignment. That's really, really important to get you caught back up, to get all the practice that you need for this. So there's a total of several problems here. So if you can do this for the first homework assignment for this particular day, would you please go ahead and start it off on this particular one. And then I'll see you later.